Now, as we have discussed earlier that when a vehicle undergoes a circular path, the maximum permissible velocity for it is under root mu rg, where mu is the coefficient of static friction between the road and the tires, whereas r, suppose this is the circular path along which the vehicle has to travel, then the radius, this radius is r, and the acceleration due to gravity. Now, the velocity is highly dependent on the value of mu, which actually decreases by conditions. For example, when the weather is rainy, so in that case the road will be wet, in that case mu will decrease. Or suppose the tire of the vehicle is already worn out, in that case also mu will decrease. So depending on the force of friction is not the safest way to provide or for the dependence of providing necessary centripetal force, right? So for a safer version of the of circular path, the new device method is called banking of tracks. What banking of tracks is? It is the phenomena of raising the outer edge above the inner edge. So instead of road like this time the outer edge will be raised above the inner edge. So that is how banking is done. You might have seen this thing very prominent in racing tracks. Like racing tracks are always made by banking of roads, about banking of tracks. Now, if you draw a free body diagram in this, have a look. Actually, I want to make a bigger diagram so that all the forces are quite well visible. So let me make the diagram only for the road. Now this is our, okay, I'll make it here. This is our levitated part of road, or the raised outer edge. This is the inner edge of the road and this is the outer edge of the road. So the circular track must be something like this, okay. Right now our vehicle is this, the tires, and consider the body. This is our vehicle, okay. What are the forces acting on it right now? First of all, weight mg, the normal reaction, excuse me, the normal reaction r is in this direction. If the road is raised, that is outer edge is raised by angle theta, so the components of r would be in this direction and this direction, right? Now also, where is the frictional force acting? Frictional force is acting because when the vehicle is taking such kind of circular path or circular turn, the skidding will take place in this part, like in this direction, if there is no force of friction. So the friction is providing the necessary centripetal force, actually not the friction, a part of friction is providing necessary centripetal force, and the frictional force is acting in this direction. So I am making the components of frictional force here only instead of making it here, so that will make the diagram more complicated. This is my frictional force. So these are two components of frictional force, right? This angle is theta, that means this angle would also be theta. So this is F cos of theta and this would be F sin of theta, right? Whereas the components of R forces, the reaction forces will be what? This is R. If this angle is theta, okay, how do we make from this? Because if we want to be sure that this angle is theta, right? So how do you make the diagram? I am doing it for a general purpose of solving how to get the diagrams or angles. I told you that this angle is this is R, and we have to make these two components. So what would be the components, right? And what is the angle which we are concerned about? See, in case of friction, this angle was equal to this angle in case of friction, right? So that is why I did, the force of friction was in this direction, so this was F cos of theta and this was F sin of theta. Now here, if this angle is theta, so that means this is 90 degree, so this angle will become 90 minus theta, right? Also this angle is 90 degree, that means this angle will be theta. This is just an explanation that which angle I am taking, what are the components in what direction by taking angle theta. So this will become R cos of theta and this will become R sin of theta, right? So that is how all the forces are acting on the body at this point. So this is the free body diagram. Actually the red part where I have represented the force of friction, just try to superimpose this the red diagram over the black one. So you will get all the forces acting in vertical and horizontal directions. So now there are two forces which are acting towards the radius of the circular path, which are what? This F cos theta and R sin theta. So R sin of theta and F cos of theta. These two forces are together providing the necessary centripetal force which is required by the body to move in the circular path, and that is why the dependence on only frictional force is eliminated. Now a component of reaction force as well as the frictional force are taking part together to provide necessary centripetal force. Also, this force R cos theta, this R cos theta is balanced by two forces. One is the weight and the other one is this component, the vertical component of frictional force, that is F sin of theta, right?